Welcome to Web Handling. My name is Dave Royston. I am super excited to continue our Material Matters mini-series with a discussion of Modulus and why it matters. Web Modulus is essential for product process and machine design. Modulus informs us whether dancer, load cell, or draw control will be easier to implement. Modulus informs us on reasonable tolerances for dimensional and position control. Finally, Modulus informs us on what winding defects can be expected. I know your time is precious, so let's get started. True, Modulus is not as popular as other measures, but I think that is a serious oversight. Let me explain why. First, Modulus helps determine which tension control methods are easiest. High modulus is usually easier to do in dancer or load cell control. Low modulus, on the other hand, can go either dancer or tension or draw control. The latter being more common because it is an easier drive control method, albeit more confusing for everyone else besides drive programmers. Second, if you need tight tolerances for dimensions or positions, this will usually be much easier with high modulus materials. For example, roll or web length or web width tolerances of 1 part in 1,000 are achievable with great care on high modulus materials, while 1 part in 100 would be challenging or even commercially impossible for some low modulus materials. Third, modulus is required for all web handling and for all winding models. MD modulus in particular tells us whether tightness is easily achieved, perhaps too easily achieved, such that perhaps crushed cores are common on springy webs. On the other hand, loose roll complaints are quite common with paper and metal, even when drive motor tension is measured in hundreds of horsepower and nip loading is measured in tons. Finally, note that modulus is different in all 3 directions. The MD modulus is most important for most problems. However, sometimes the ratio of MD to CD or MD to ZD are most relevant. Modulus is tested with very similar test equipment and methods as we saw in the last clip for tensile strength. Perhaps the only major difference is how the raw stress versus strain test data is gathered and then reported. Some tensile testing machines are not able to do this due to some combination of hardware or software or programming limitations. From Appendix T of the must-have 750-page Web Handling Handbook, you will find the 2 most common test standards for modulus. For the more advanced audience, there are further complications because there is not just one modulus for one of each of the 3 directions. There are actually 4 common definitions for each modulus in each direction. They are Young's modulus, chord modulus, secant modulus, and tangent modulus. All are similar but slightly different definitions and depend on where on the stress-strain curve that you take your data from. Fortunately, most of us do not need to worry about any of that. We are served nicely by just one convenient definition for MD modulus for most things. Here is a table of some examples of moduli for some common materials. As you can see, they vary by about a factor of 1,000 between a rubbery nonwoven to aluminum foil or strip. Yet, all must be handled appropriately by proper design and tolerancing of web handling mechanicals and controls and product specifications. Sometimes we need to do multiple materials on a single machine, and that stresses everything about the design. While we're at it, now would be a good time to briefly review the idea of brittle and ductile behaviors and why it matters to web machine design, as well as the mix of problems that you are likely to encounter. While ductility and modulus are totally separate material properties, they often tend to trend together for most chemistries and grades. For example, high modulus materials require tight mechanical and control and web quality tolerancing, and those webs may break at the slightest provocation. On the other hand, low modulus materials tend to be very tolerant for machine mechanicals and controls, but on the other hand, very intolerant of tight dimensional tolerances of the web itself. Of course, modulus and ductility are on a grade scale. Of course, ductility can change for the same material under different conditions. For example, dry paper is brittle, while web paper is ductile. While film is usually ductile, it can become brittle if temperatures are really low. There are two places where you will find much more about web modulus and its application. The first is the must-have 750-page Web Handling Handbook, written by myself, Tim Walker, and Dylan Jones. Also, of course, is my award-winning and trademarked Web 101 class that has been taken by about 5,000 people, just like you. Here you will learn how to use material properties and testing to size and maintain and operate and troubleshoot web machinery. Thank you so very much for joining me in this Material Matters series. Stay tuned for the next clip where we will discuss friction, what it is, how you test for it, and why it is super important for many problems. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.